Okay, exercise 512. This is extension 1, content. Solve 1 over x minus 1 is greater than 3 graphically. If I don't ask you to solve it graphically, you would do it algebraically. Do you remember how you do this algebraically? Inequalities, that means less than, greater than, less than or equal to, greater than or equal to. Inequalities with x in the denominator. This is that type of question. We learn how to solve it algebraically by multiplying both sides by x minus 1 squared. Do you remember? And then we took everything over to the left, we factorized, and we solved. All right, look, we might do this one both ways so that you can remember how to do the other method. So solve this graphically. Now, to solve graphically, we sketch. See, this is asking me, where is this curve on the left higher up than the line y equals 3? So we sketch y equals 1 over x minus 1, and we sketch the line y equals 3. That's our first step. Sketch both these functions. So to solve this graphically, you sketch the left-hand function and the right-hand function, or relation, or whatever they are. And then we need to see the points of intersection, and then we need to see where the curve on the left is higher up than the curve on the right. Okay? So let's go. So let's have a quick sketch, and I mean a quick sketch because then algebraically we will find the points of intersection. Oopsie, wrong. Where is this shifted to? That's right. So the asymptote is here. This is not curve sketching menu, the 4 steps, because it's just 1 over x minus 1. When you see that, you can say, right, yep, that's a hyperbola shifted where? 1 unit to the right. Quadrants 1 and 3 looks like this. While we're here, might be an idea to find the something, the what? The y-intercept. When x is 0, y is -1. So that's that curve at the moment. So I've got my y-axis, I've got my x-axis, I've got my asymptote at 1, and the graph is there in black. That is y equals 1 over x minus 1. Sketch the line y equals 3. What does that look like? Horizontal line going across. And I'll just put it up here somewhere, as long as it's roughly in the right place. That's 3. This is the line y equals 3. Now, there are points of intersection. So here is a point of intersection. There only appears to be one point of intersection. Okay? I need to find what that point of intersection is. How do you find point of intersection? You put them equal to each other. So instead of putting this greater than 3, you put 1 over x minus 1 equals 3. So we're going to find the point of intersection between the curve of the curves 1 over x minus 1 and y equals 3. So we go 1 over x minus 1 equals 3. How many answers do you think I'm looking for based on my graph? There's only one point of intersection, not 2. There's only 1. So how do I do this, girls? I can go 1 cross multiply equals 3 bracket x minus 1. So 1 equals 3x minus 3. Taking that 3. I've got 1 plus 3, which is 4, equals 3x, or x is, careful, 4 on 3, which is 1 1/3. That makes sense. Can you see how the point of intersection is just after x is 1? So this is the point 1 1/3 something. I mean, actually, we know what the something is. It's 3. Okay, that's the point 1 1/3, 3. So I only need, see how I'm asked to solve this graphically. I'm only solving for x, I don't need to solve for y. So this is asking me, where is the hyperbola higher up than the line y equals 3? Look at the graph. Yeah, well, no, it's here. This is where the hyperbola is above the line y equals 3. I've shaded it. This is where it is higher up, right? It's lower. It's lower here. It's lower. It's below the red line. It's below the red line. How do I talk about these values? Well, it's never x is 1. It's bigger than 1. So my solution is x is bigger than 1, but lower than 4 on 3. Now, it's an inequality without a greater than, it's not greater than or equal to. If it was greater than or equal to, I would have less than or equal to here because it actually includes that point as well. But it will never include 1. Why? Because x can't equal 1. So it's all these values of x between 4 on 3 and 1. Between 1 and 1 1/3. It doesn't include either one because this inequality doesn't have an equal sign. All right, so that's solving it graphically. You okay with that or no? Now, let's solve algebraically. So a revision. No. Let's solve it algebraically. All right, so we go. This is, you look at it and you say, this question is inequalities with x in the denominator. To solve this algebraically, see, the problem is I don't know how to solve this because I don't know if x minus 1 is going to be positive sometimes or negative sometimes, depending on the value of x. That's why I multiply both sides by x minus 1 squared. Remember that? And cancelling on the left-hand side, we've got x minus 1 is greater than 3 bracket x minus 1 squared. Now, you either want to use negatives or you don't. I don't want to. I don't mind what you do. You can do what you want. What do you want to do? You can go to the left, go to the right. We can go to the left. Bring everything over to the left. Right, so remember, don't expand these. Multiply both sides by x minus 1 squared. Take everything over to the left. What's the next step? Factorize. Don't expand. What's a common factor? X minus 1. Now what have I got? 1 minus 3 bracket x minus 1. Remember this? Which is x minus 1 times, isn't this 1 minus 3x plus 3? Is that right? 1 minus 3x plus 3. 1 plus 3, that's 4 minus 3x. Oh, what do we have? What is that? Well, yeah, look at it. If you multiplied that throughout, that's 4x minus 3x squared. That's all I need, the minus 3x squared. So I'm actually going to put this equal to 0 and solve. And solve. And what do I get? X is 1 and what? X is what? I need the points. 4 on 3. Because I've got, and then I've got 4 minus 3x is 0. 4 equals 3x. Be careful, x is 4 on 3. So I sketch it, remember? And 4 on 3. Girls, concave up or down? Parabola. If you multiply the two x terms, it's a concave down. Okay. So we come back here and we need to solve this. So how do I solve? This is a quadratic because when I multiply it out, I get 4x minus 3x squared. That's all I need. It's concave down. It cuts the x-axis at 1 and 4 on 3. They're my x-intercepts. Where is this parabola? Above, below, or on the line? You tell me which one. Where is it? Greater than 0. Where is it above the line? Between 1 and 4 on 3. Now, go back to the original question. Is it greater than? So I don't want any equal to's in my answer. And x can't equal 1, so I don't, it's correct like that. It's the inequality without the equals. Do you get it? Is that the same answer as what we got before? One solved graphically, one is solved algebraically. Okay? Question 9, solve negative 1 over x minus 1 is less than or equal to 3 graphically, and we're also going to do it algebraically. So you can revise how to do it. Okay. See, this one's easy to draw because it doesn't have an x on the numerator. It's just a negative hyperbola. See, negative 1 on x is the negative hyperbola, quadrants 2 and 4, and the minus 1 means it's been shifted sideways. Where? To the right again. But it's the negative hyperbola. So it would have been quadrants 2 and 4. It's shifted 1 unit to the right. It's still like quadrants 2 and 4. But it looks like that. And this is 1. So that's my hyperbola, -1 over x minus 1. While we're here, let's throw in the y-intercept. When x, so we're going to sketch y equals -1 over x minus 1 and y equals 3, and then we're going to find the point or points of intersection. And what have we got? I can just put y equals 3 roughly. Again, there's only 1 point. So I'm going to have to do some others that actually have more than 1 point. I'm going to do 2-point ones in a minute. Make one up myself. Okay, 1 point of intersection. Where, and that point is what? Between 0 and 1, isn't it, from your sketch? The point's between 0 and 1. How are you going to find the point of intersection? Anyone? Equate them. In other words, equate means put them equal to each other. So -1 over, this is the line y equals 3. -1 over x minus 1 equals 3. If they say solve graphically, you must sketch. If they don't, if they just say solve it for x, you can do it any way you want. Okay, so what have I got here? -1 equals what? 3 bracket x minus 1. -1 equals 3x minus 3. What does 3x equal? Try not to make a mistake. 3x equals 2. -1 plus 3 is 2. And what does x equal? 2/3. Does that make sense when you look at your graph? It does. It's between 0 and 1. So if you've gone and put 3 on 2, you might think twice about that. All right? So now it's asking me, where is the curve, the hyperbola? When I look at the question, it's telling me, where is the hyperbola, above or below 3? Where is the hyperbola less than or equal to 3? Do you see it's asking me for below? So I want the hyperbola to be below. So here I'm going to myself, where is the hyperbola below the line y equals 3? That's what you're asking yourself. See, it's the hyperbola is less than 3, below it. So let's highlight where it's below. Oh, it's below a lot. Okay, let's have these values. These go on forever. The point of intersection is what? 2/3? The point of intersection is 2/3, 3. So this has an x value of 2/3. So which values of x? What are these values of x? X is less than 2/3, good. So I've got, this is 1, the asymptote's at 1. The values I want for x, sorry, this should be sort of coming up closer to the curve. I should actually draw this a bit more like that, so it doesn't look so straight up and down, you know. It's more like this. So where is the curve? Below the line. X values are less than 2/3. Wait a sec, less than or equal to? Look at the question. Yeah, before we even start, what can x never equal? So let's just put over here, x can't equal 1. So anywhere in my solution, I'm going to circle that. Make sure you haven't got x is 1. X is less than or equal to 2/3 is allowed, as long as x isn't 1. All right, what's this one over here? I need this. So this is where we say x is greater than 1. See, when you look at the inequality, you might be tempted to put x is greater than or equal to 1, but that's when we look at the denominator and say, wait a sec, I can't put greater than or equal to. All right? X is greater than 1. No. When they go two opposite directions, you can't. It's only if it was between those two or something that you could. See, x is going this way and x is going that way, so you can't. Now let's do this one as well, algebraically. Remember, Negative 1 over x minus 1 is less than or equal to 3. What do we multiply both sides by? Yeah, so negative 1 over x minus 1 times x minus 1 squared is less than or equal to 3 bracket x minus 1 squared. And what does the left-hand side become? Negative bracket x minus 1 is less than or equal to... Now, you know what? I'm not really a negative person. Let's go for the right. Let's put everything over to the right. 3 bracket x minus 1 squared plus x minus 1. If you take it over to the left, you're going to have negative, negative. 3 bracket x minus 1 squared plus x minus 1 is greater than or equal to 0. You okay with that? Big open mouth faces the expression, pointy end faces 0. 0 is less than that, or that expression is greater than 0. Yes? Nice. Factorize out the x minus 1. And now what have I got? You don't expand it. 3 bracket x minus 1, what? Plus 1, greater than or equal to 0. X minus 1 bracket. 3x minus 3 plus 1. Try not to mess it up. 3x minus 2. If you have to write out the extra line, write out the extra line. Actually, I would write out the extra line. You put this equal to 0, our solutions are 1 and 2/3. Looking good, looking good. Right, we have to sketch this. This is a quadratic, in other words, it's an x squared function, inequality, greater than or less than. Is it concave up or down? 2/3 and 1 are the points of intersection. It's concave up. I need my curve to be greater than or equal to 0. Up here. Be careful. Go back to your question and look at what x cannot equal. X cannot equal 1. Make sure you don't have an x equals 1 in your solution. Right, let's go. What are the solutions? X is less than 2/3, x or equal to, yes, because the question has an equal to. So yes, we want to put equal to's unless we hit x is 1. We were going to put x is greater than or equal to, but we're not allowed to put x is equal to 1. So it would have been equal to, but we're not allowed to put it for x is 1. Same solution as before. X is less than or equal to 2/3, x is greater than 1. Okay. Now, solve this graphically and algebraically. Now, when you look at it, you might think, oh, that's a hyperbola, shifted. It's not. Well, it might be part of one. When you've got the x on the top, that's the further curve sketching, that's the curve sketching menu, that's the 4 steps. That's y-intercepts. Is it even or odd? Where are the asymptotes? Where are the horizontal asymptotes? Where are the vertical ones? How do you recognize it? It's x over x plus 2. Look at the last two we did. 1 over x minus 1. So the x, once that comes in, it's not your straightforward hyperbola anymore. Okay? We actually can do it like that. I want to show you something. So let's not do curve sketching menu for a sec. We're going to do it another way. Sketch, maybe, x plus 2. Yeah, I think we can do it another way. Sketch y equals x over x plus 2 and y equals 4. Now I did show you, so normally, yes, curve sketching menu. I just want to show you something else. Y equals x over x plus 2. I want to show you something. That's x plus 2 minus 2 over x plus 2. Why am I doing that? Because when you've got an x over an x, you know the curve's often shifted up or down. Are you okay with that? Why did I choose x plus 2? Because x plus 2 is on the denominator. So x I've written as x plus 2 minus 2. Does x equal x plus 2 minus 2? All right, I've got a fraction. I'm going to put this bit together. So that's x plus 2 over x plus 2 minus 2 over x plus 2. How are you with that? I have done it once before on the board. Now, when you've got that, x over x plus 2, you can't just sketch it. You need to either do this, it will be shifted. As long as it hasn't got the x squared, you're okay. You know how we had a lot of those others, x over x squared minus 1. Once the x squareds are in there, forget this. You probably can't do it, all right? But while they're just x's, this will work. So that's x plus 2. So, you know, with a fraction with the same denominator, it's x plus 2 over x plus 2 minus 2 over x plus 2. Are you okay with that? Well, what's x plus 2 over x plus 2? 1 minus 2 over x plus 2. Well, you know how to sketch that now. Don't worry about the 1. That's really negative 2 over x plus 2 plus 1. In other words, it's that hyperbola with the numerical numerator, which is fine. Shifted 2 units where? To the left. Is it in quadrants 1 and 2, 1 and 3, or 2 and 4? Quadrants 2 and 4, and the whole thing is shifted up 1. So we can sketch it. So let's sketch it. So we're going to sketch that and the line y equals 4. So where is it shifted again? To negative 2 across and 1 up. So it's shifted 1 up and negative 2 to the left. So that's y, that's x. Which quadrants? Quadrant 2, quadrant 4. Now, it might be a good idea to work out what the y-intercept is while I'm here. So y-intercept is when x is 0. I don't mind if you do it in the original function. Oh, it passes through 0. It's 0, 0. That's why I needed to find it out. See? I started sketching. Good idea to know where the y-intercept is, isn't it? Where does it pass through? That makes it nice and easy. That's it. Got it? Passes through 0, 0. So now you can sketch it properly. So we've sketched that. Y equals x over x plus 2. So I didn't need curve sketching menu after all. Sorry, I shouldn't have said that earlier. Because if it's when you've got that x squared that you'll need the curve sketching. All right. So, because you know why this numerator can be easily made into the denominator, which means 1. And then you'll just have a number. So it's just a shifted hyperbola. Now what do I need to sketch to do this question? I've sketched the first function. Now I sketch y equals 4, which will be up here somewhere. Actually, we're going to solve both inequalities. I'm going to do the greater than or equal to and the less than or equal to, just for practice, all right? So, let's go. Where is the hyperbola, above or below the line? Where is the hyperbola? Anyone? Look at the inequality. Hyperbola above or hyperbola below? Above. So where is the hyperbola above the line? So, to solve, actually I haven't found the points of intersection, have I? We need the point of intersection. What is this point? So what do I do that? What do I do now? I equate, but just do the original one, it's easier. So I need to solve to find the point of intersection. Solve x over x plus 2 equals 4. You don't have to do the other one. What have I got? X equals 4 bracket x plus 2. X is 4x plus 8. I've got 3 x's, negative 8. This is looking good because my value's got to be less than x is negative 2. It's negative 8 on 3, which is negative 2 2/3. Great. That's looking good. Makes sense with your sketch. So what's my solution? So the solution is, the solution to this is, where is the hyperbola above the line y equals 4? Well, it's there. Now this is an x value of negative 8 on 3. So is this a greater than or equal to? Yes. So it's, well, x is between, come on, go. Between what? Which one's smaller? You always do the smaller value first. So it's negative 8 on 3. Do I put an equal to with that one? What can x not equal? So that's a less than 2. So it approaches the asymptote but never touches it. Negative 2. Negative 2. X can't equal negative 2, so it's between negative 2 and 2/3 and negative 2. Woms, if I asked you to solve x over x plus 2 is less than or equal to 4. We've done all the work. Solve, you tell me where the graph is below the line y equals 4. I'm going to call this part A, part B. Yeah, so I need all of this now and all of that. How do I solve that? If I want to solve where is the hyperbola less than the line y equals 4, what do I get? So the solution is x is less than or equal to negative 8 on 3, that's those x values, and x is greater than negative 2. All right? And if it was just less than, that would be a less than. Okay. Oh, let's solve this one, what's his name, with algebraically. So solving algebraically, have a go? Good revision. The original algebraically. So now we're just going to solve, everyone got that? X over x plus 2. So we're just going to solve x over x plus 2 is greater than or equal to 4 algebraically. Oh, remember how we do it? Multiply both sides by x plus 2 squared. Oh, this is a good one to do because what are you going to do now? I don't mind left or right, it doesn't matter. Let's go to the left actually, because I think we're going to get a negative cubic or something. Let's go to the left, because you still don't have 2 negatives, you've only got 1. So we're going okay. Multiply both sides by x plus 2 squared. Cancel, you know, one of them. Bring everything over to the left because it's not going to give us 2 negatives. What are we going to do next? Factorize out what? X plus 2. And we've got x minus 4 bracket. Sorry, no, it's not a trinomial. It's not a polynomial. Like, it's just a quadratic. Simplifying. X minus 4x minus 8. What do you get? X minus 4x minus 8. Negative 3x minus... Let's put it equal to 0 first. You know, just be very careful with this. I'm going to do something here. You know, negative, negative. Why don't I just pull a negative out and write the 3x plus 8 first and the x plus 2. How about that? You okay with that? I'm pulling out a negative, negative there. So it's negative bracket 3x plus 8. Just make sure that you don't mess up your solution. So what's your solution? X is what? Negative 8 on 3 and negative 2. Concave up or down parabola. X times negative 3x, that's a negative 3x squared. That's down. Which point is further to the left? Negative 8 on 3 or negative 2? Negative, you've got to get that right. That's negative 2 and 2/3, that's negative 2. And it's asking me, where is the curve, above or below? Above. Look at the original question. What do I write? X cannot equal negative 2. Come back down. All right, that's important. So where's your solution? Between Negative 8 on 3. Do I put an equal for that one? Negative 8 on 3 less than or equal to x less than 2. No equals, sorry, less than negative 2. Not equal to negative 2, please. All right? Oops. Ooh. Okay.